Dobar dan, dobri ljudi, good day, good people. Today I want to take 15 to 20 minutes of your time, and I really do expect there will be some questions at the end to talk about how Web3 ecosystems and protocols evolve, the lessons we can learn from it when it comes to bringing the next wave of adoption to Web3. So a bit about myself, I'm not Web3 native. I didn't start off in Web3. I started off as a system engineer at Devana, later GoDaddy. My Web3 journey started with MVP workshop, Attic42 today. And for the past 2 years, I think the most relevant experience that I've gotten that put me in a place where I have things to share with you, some insights to share, was during my time as a co-founder and CTO of Trapezis. In Trapezis, we worked on development for Polygon Edge, the blockchain client that's behind the Polygon Supernets program. It is an app chain program designed to bring new people and organizations into the world of Web3. So, as a Polygon development lead and Supernets tech lead, I want to talk about the things that we've learned. I feel it's obligatory to give you a due notice that what I want to share with you today is because of my passion for showing the value that Web3 can bring to organizations, both startups and enterprises. The insights that I want to give are the insights that shaped the product that we are building right now, Route 3. But this talk isn't about Route 3. This talk is about the insights and about bringing more people to build something for the multi-chain future. So I just felt obligatory to share that with you before we start. So to kick things off, I want to talk about the early days of developing Polygon Edge. When we started developing it, app chains wasn't that much of a popular word. You could hear it in some circles, but in general, people didn't know what app chain thesis was, what are application-specific blockchains, and what's the point of them, really. So we thought of Polygon Edge as primarily an enterprise Ethereum client. That brings some associations with it. When you talk to large organizations, when you talk to large enterprises who you want to onboard to using Web3, what they do is really just natural to find common ground between Web2 systems and Web3 systems. That common ground is, can this system support my level of operations? Does it have the scale I need to support all of my users? So every call that we had, every exploratory conversation that we had ended like this. So we were always developing frameworks for better and more empirical load tests, for getting more correct numbers for the transactions per second that our network can get, just in order to show these large organizations that we are able to support them at scale. And the general train of thought that was present at the time, that after enough learning, I must say that these organizations that we helped learn the ropes of Web3, they really gave all they have into studying, into approaching this industry, knowing that they are not here to shape it, but they are here to adopt the principles. And I must say that they've done an excellent job. And we've also done an excellent job at getting formidable transaction per second numbers. But instead of the future looking like this for a lot of them, because you have the TPS numbers, you understand what Web3 can give you, you get it all. The reality is a bit different. You get a network, highly performant, hundreds, thousands of transactions per second are possible to be finalized with one block finality. But then you realize, okay, I get a network that's essentially just an RPC and a virtual machine to where I can deploy my smart contracts, which is not enough. The users expect some level of user experience that's not solely provided by the network itself, no matter how performant it is. Users need block explorers. It's what Web3 users are used to, and app chains have a hard time getting to it. Users need bridging infrastructure and UI, RPC providers, Oracle services. You need to pull some data off-chain, put it on-chain to provide necessary data for DeFi protocols to work. You need fiat on-ramps. A lot of these application-specific blockchain use cases really depend on having a way to on-ramp TradFi into DeFi. And last but not least, you need development tooling. If your app chain is building an ecosystem of its own and not just deploying your app, you need to support those developers. Luckily, developers of today are really spoiled by all the awesome tooling that exists for them. And this tooling, we need to bring it to app chains. So the thing is that not just the cost, not just the level of complexity of closing all of these deals and making all of this possible for your users to have the experience as they have on an already successful and established layer 1 network, but it also costs a lot. Like, imagine if you could, if you would say somebody, okay, you can get a block explorer, but annually we're talking on the level of $1 million just to have the best possible block explorer experience for your users. Let's say that organizations then decide, okay, but we might not need block explorers really. But when we talk about Byzantine fault tolerance and achieving security, the way Web3 was designed to achieve security by decentralization, when your network has no intrinsic value, when your network has no token value of its own, what happens is that you need to make deals with people to compensate in fiat to bring you validator infrastructure. That validator infrastructure is not cheap at all, especially if we take into account the most popular consensus mechanisms for app chains, which all recommend minimum set of 4 validator nodes for your network to truly be Byzantine fault tolerant. We get to somewhere around 20 to 60K monthly fees. And that's just shy of $500,000 yearly, just for the basic infrastructure to keep your network decentralized and secure. That's a lot. Why is it like that? That's the thing that I want to talk about, and I like to argue that it's because of how Web3 protocols evolve, really. The example that I want to take that I feel is really good at explaining why is it due to the evolution process of Web3 protocols and networks is the biggest one and the most recent one that took place last year, Ethereum's transition from proof of work to proof of stake. Of course, I just want to say I'm really humbled by the level of effort and coordination and a lot of research that these smart guys took so that I can talk about the reasons that I think have brought us all to this moment. First of all, I'd like to argue it's not just an effort to improve energy efficiency. Why do I think that? Because energy efficiency on its own has been an argument attacking Web3. It hasn't been an argument coming from Web3. We talk about energy efficiency when people come and say, but look, you guys consume the electricity yearly that a small to medium-sized country does. I haven't heard people in Web3 being super concerned about that before being attacked by those arguments, simply because nobody thinks about how much does a medium-sized bank consume electricity. Nobody knows how much electricity does entertainment services that we use each day consume. We do not have a way to even getting to those numbers. With Web3 we have, and of course it's just natural that it's put under scrutiny to look at the energy efficiency. Don't get me wrong, energy efficiency is really important, but it's not the most important part of moving to proof of stake. I'd argue it's an effort to not rely on AMD and NVIDIA. Essentially, the GPU manufacturers are the ones who provided the essential things for securing the network. Most of you have some funds on Ethereum. Those funds are essentially secured by the hardware that these two companies provide. These two companies have their own ways of thinking, they have their own goals, they have their own customer personas that they want to cater to. Gamers weren't happy at all with the introduction and bigger adoption of Ethereum protocol simply because there were less GPUs for them. But for Ethereum itself, what this meant was that the core tenet, the core principle of why we're building Web3, to achieve security through decentralization, to achieve rule setting without authority, we have to rely on some external companies. So with the migration from proof of work to proof of stake, some may argue we're now at risk from Lido. I just want us to all be completely aware that Lido isn't NVIDIA. These guys, these really good folks working at Lido are Web3 native. They're self-imposing limitations to them so that they do not put the network at risk due to too much of centralized stake being in their staking pools. Something that companies like AMD and NVIDIA wouldn't even think about. The sole purpose of migrating from proof of work to proof of stake is making sure that all the actors in the system are completely aligned. I felt it was needed to put this slide in the presentation, sorry. It's like everybody needs to mention ChatGPT, but really in this context with, for example, generative AI and the potential it has and the potential for demand in GPUs, it can create this entire wave of mass adoption of generative AI. It really makes Web3 even a tinier speck on the radars of these large GPU manufacturing companies. So I'm really glad that we migrated from proof of work to proof of stake at the right time, because it might have been too late a year later. One of the things that this essentially provided for Ethereum was self-sufficiency. This is a depiction of an ancient symbol found in many different civilizations, which is called Ouroboros. It's a snake eating itself. It's a symbol of self-sufficiency, of regrowth and regeneration. Basically what Ethereum accomplished with proof of stake, which I think is the most important lesson that we can all take, especially people trying to build their own app chains, is that the product of your network, the value that you create, should be the thing that secures it. Not something external, but the product of your product should be the security it provides. We all know that multi-chain is the thesis that a lot of people are proponents of. Because multi-chain simply means that we're able to break free of the limited capacity of the networks that we have today, to migrate from the analogy of shared hosting to dedicated hosting, where we are able to use a network, a Byzantine fault-tolerant network, or a ZK rollup to its full potential, not being fearful of censorship or not being fearful of huge gas fees because of somebody else's popularity. Vitalik even says that he's optimistic about multi-chain, right? But let's get back to the problem that we have in order to accomplish that and how we might take lessons from Ethereum and apply it here. First of all, are the huge costs. We talked about $500,000 just to operate the essential infrastructure that brings you security. And if we compare that to the world of Web2, where you, as a startup that needs a lot of financing on its own, but right now you need $500,000 just to pay your infrastructure bills for 1 year in Web3. In Web2, cloud providers are rushing your way to give you cloud credits because they see the potential in you to be a big lifetime value customer. On the other side, enterprises all the time try to find use cases for using different cloud infrastructure. Cloud credits work well in this sphere as well. Cloud providers give you credits so that your enterprise can see that you have the better offering than the competitors, and that you are able to then migrate as much of your infrastructure to their cloud as possible. So when we compare what the deal is in Web 2 versus Web 3, the gap is enormous. Huge costs versus people giving you a lot of cloud credits just in the hopes that you would be a long-paying customer tomorrow. The second thing is that is really a friction point in people and organizations adopting app chains is that one size shouldn't fit all. I don't know if any of you visit this forum from time to time to keep on top of developments and trends in the Ethereum ecosystem. But Ethereum Magicians has been running for a long time. A lot of really smart people have collaborated there, have shared their ideas on what Ethereum is, what Ethereum should be, and most of these ideas don't get into production, which is just natural. If we were to implement all of those into our Ethereum compatible blockchain clients, the network wouldn't be as supportive of all these projects as it is today. If Ethereum's 240 issues on GitHub, I think I took this screenshot a couple of days ago, if those 240 issues are anything like the issues that we had at Polygon Edge, where people just want to put their features into the client and want to make something work for them, not understanding that this is something that needs to provide infrastructure for everyone, then it's just discussions about whether we could put this cool feature that works for me, but perhaps doesn't work for everybody else. That is the problem with, adopting something that you really cannot fit all use cases into one specific execution environment. That's the second problem. The third problem is that we often forget why we favor decentralization at all. Decentralization is here simply because it gives us the cleanest way to achieve security, to put rules that don't require authority to enforce them. The state of the app chain thesis, I think, looks like this. People think that small validator sets are doomed to fail, that networks with not a huge list of validators are doomed to fail. What I want to argue is that if your network doesn't have that much funds to begin with, that much TVL to begin with, why do you need a large decentralized validator set? What are the economic incentives that you're going to build for those people so that the network becomes sustainable in the long run? It just doesn't make sense. When we have something to secure, that's when I think we should start moving towards security and decentralization. Decentralization shouldn't be done purely because it's a nice buzzword, but because it brings us security. And to have security means that we have something that we are really in need of securing, not something that an app chain that I can create this evening will have in the next couple of months. The other, somebody might argue that, but there are cheap and affordable ways to decentralize with a couple of clicks. Blockchain as a service providers do just this. I want to just state that having 100 validator networks managed by a single company is essentially the same as having just one validator, because it's one entity. If it gets compromised, it's just a couple of extra hops for somebody to SSH into all those 100 servers to overturn the network. But it's just extra steps, not extra security to compromise it. I'd also say that one validator network is essentially superior to a network with 100 validators managed by a single entity, simply because of performance, because of the complexity of message passing that we have a consensus. It's just pure graphs and maths, nothing complex. But even with all things stated, we have a bigger problem that we've observed. The cross-chain insecurities. Like if there are any Ethereans here who visited that Reddit post I've shared from Vitalik a couple of minutes ago, you'd be angry because I on purpose cropped it to hide the real concern that Vitalik has. Although multi-chain thesis, app-chain thesis is a really lucrative way of onboarding people to Web3, onboarding organizations to Web3 so that they can onboard their user bases, the cross-chain applications are worrisome. We've seen, I don't want to talk about all the hacks that we've seen, but bridges are a big critical piece of infrastructure that we need to take extra care in operating. But we need to think of bridging from two perspectives. One is the purely technical perspective. Is this code audited? Is this hack-proof? Nobody can find a backdoor into the bridge. Nobody can exploit a smart contract vulnerability. Bridges always involve smart contract when we're talking about Ethereum ecosystems and Ethereum-compatible ecosystems. And a lot of things can break, but that's just one piece of the puzzle. The second piece of the puzzle is keeping that bridge properly, keeping all the actors in securing the bridge properly incentivized and aligned. So this is a graph that should represent total value locked of an app chain network. So what does go into these numbers, into the sum of a network's value in fiat? First, the native currency, the tokens that the app chain has, but most importantly, if the network opens its way to bridging, especially in the early days, this is most influenced by the funds coming in and funds coming out, because those are usually well-established projects with values of their currencies much higher than the native currency of the app chain. So we see something like this. And we know that what makes up most of the total value locked once bridging is enabled are currencies bridged from other networks. Another very popular thing today, which I think is good, is that we are using POS for securing these networks. You can imagine the level of attacks we as an industry would have if app chains required for people and organizations to go and purchase GPUs to secure it properly. But essentially, especially in the nascent days of a network, the total value stake doesn't fluctuate as much as TVL. Users can influence TVL. You can bridge in, bridge out, do something on the network. It should have its own utility and function, so you would want to come to it, but the total value stake should change only when somebody else delegates to a validator, when a validator enters the pool of the validators or exits. So it doesn't change as much. But this opens up to a huge risk. At this exact points in time that you can see on the graph here, where the total value locked, which is mostly the funds bridged into the network, are more valued than the stake, the total stake that's securing the network. What that means is that the validator set is able to do an honesty arbitrage. The validator set is able to come in and say, look, I'm a neutral actor here. In Web3, we all depend on the rules that we've set based on the incentives that we have. I know that I won't be coordinating an attack on this network because it just isn't profitable for me. But in these exact moments in time, it's profitable. All the stake you could lose is worth less than the bridged funds that you would get. Not only in one moment would you be able to shut down this entire currency, but you would also be able to unlock the bridged funds on origination chains, which is a huge issue. My thought on this is that before staking third-party tokens, before starting to do a lot of bridging operations, you really need to make sure that you've kick-started your own chains economies. Because without them, there's essentially no tech that can keep you secure. To recap some of the things that we've been talking about, the recipe for a successful app chain, as I see it, is first to have predictable and affordable costs, not to have something that's way above your scale and that will give you $500,000 cloud bill, validator bill at the end of the year. Second is to have the ability to make choices. One size doesn't fit all, and I'm glad that we have a lot of different ecosystems doing the things necessary to create really modular and customizable app chain networks. Third is that decentralizing should be done solely because of security, and it should be done on proper financial incentives. Without it, your network is very vulnerable. The reason why I've told you all this is because this is the way that we want to solve the app chain adoption problem for startups, both from Web3 and Web2, for enterprises. And these are the core tenets that we've built into our product. The product we will be launching this summer. I'm open to talking about it, but more importantly, what I want to do now is to give you all these insights that I think are valuable, because what the industry lacks, what the app chain thesis lacks at this moment, are app chain native tooling, are app chain native SDKs. SDKs that don't rely on these huge networks that took a lot of time and effort to build, and now I'm gonna be the first block explorer on this new L1 that we built. No, let's build the first tooling for the next 1,000 app chains that are going to arrive. That's what I want to invite you with this talk. Just like Ethereum became self-sustainable by building proper economic incentives and doing what made sense to the network at the time, Route 3 is here to help app chains do the same thing. Thank you for listening to this talk.